All righty. Good morning, good afternoon for those of you present live. Welcome to the Diesel Drivability Roundtable. My name is Tony Salas. And if you've been watching us on YouTube channel, those of you that are watching the recording, thank you for actually watching. So therefore, we appreciate it. For quite a few views we got on last month's video I saw. So that's pretty good. We're growing. And obviously, we appreciate those of you guys that took time of the day to actually take a look at this. We have tried the roundtable in the evenings, and it was not successful. So if it's something you think we ought to bring back or look at for the evenings, let me know. But noon Eastern seemed to work pretty good. We were pretty happy about that. But definitely something to look at again in the future. Or maybe we can do a day one and night one. I don't know. So definitely can look at that. So today we got Mara Gooding. Did I pronounce that correctly, Mara? Sorry.
Got him.
Godding. So Mara Godding today. She'll be speaking here in terms of talking about after treatment. So we're going to give her all ears, but just a few things going on. We have quite a few training events going on. Definitely, if you haven't been, I guess the one thing I will, let me just push. I'm going to do a commercial. Well, it's my baby. Well, I can do. There you go. Um, we need your participation. I know a lot of you. I'm like Matthew's online. I saw he's there. We definitely like you to join the Diesel Training Group. It's free. And what it is, it's a blog or a forum. I have so many new names in technology, but in my time, it's called a forum. But anyways, it's a blog. So if you want to join for free, and it's technicians helping technicians. This morning's already, I already got like a few people in trouble with L5Ps and other things, so other issues. So I'm like, post it on the forum, please. Yes, I do help people online. I mean, on the phone, but sometimes it'd be nice if I saw more traffic on the Diesel TG website of technicians helping technicians. So if you have a war story too, as well, if you have a drivability issue or any kind of diesel event that you had or something you want to share, by all means, please put it up there. So therefore, definitely that. I try to leave everything there. That's why I do not, because I've been getting questions why I do not have a Facebook page. The previous Facebook page that you may find in your search, actually, Facebook is being a pain in the butt to get our login passwords. So it somehow got lost, and I had somebody else run the Facebook page about 4 years ago, and haven't been able to get unlocked and get access to that. So for the meantime, I believe the website does better. So therefore, I will do that. But eventually, yes, I'll get an Instagram. I'm getting questions about that and Facebook page too. We'll get that later on. So, um, after treatment, we've been talking about after treatment a lot in the past forums. It continues to be an issue. This last week, I was at a shop, and even in previous phone calls. And the question I always ask, and Mara, I guess you might do this, is that I ask them, has anybody had after treatment training? In other words, do you know what a DPF, DOC, how that all works? And it's amazing the majority, how many do not have or have had any formal training with after treatment. So obviously, in my classes, one of the things I push hard because of the fact that I get a lot of phone calls about it was after treatment. So therefore, on even on my website, excuse me, not on my website, on my YouTube channel, my original first video was an introduction to after treatment, and I've updated and I came up with 4-part or 5-part series on that. So if you want to watch that on the YouTube, you're welcome to. Obviously, I'll be updating that because we got a few changes. So with that said, I'm going to give Mara, if you want to go ahead and share, I'll stop sharing my slide and I'll come back to it. But definitely you can start your share and you can share your PowerPoint. I take it is. So
Yeah.
you can put it up there. And there you go. There's Mara there. All right. So she's going to do her own thing. So Mara, we'll have you introduce yourself. Tell us who you are, what you do, and what you feel is going on. And we'll give you the floor. There you go.
All right. My name is Mark Godding. I am the technical support manager for Disnex Emission. We focus on class 6 through 8, so medium and heavy duty after treatment system components. I travel around and do training events. So, as Tony was saying, a lot of technicians have never had any sort of formal after treatment training. So, I travel around the country and our distributors will host training event nights, and I go and do a training event and at least start with teaching people the basics. Um, how to troubleshoot. What do the parts do? Why do they fail? How to figure out what caused them to fail. So, to start off, we will just do a quick overview of when the different technology came out. Some of this may be a little bit different for light duty. So it At some point, the EPA said we have too much, the NOx and the soot or particulate matter entering the atmosphere is bad for the environment. So, as of 2004, they set a standard that NOx needed to be reduced. So, they did this by adding the EGR system, exhaust gas recirculation. As of 2007, particulate matter or soot needed to be reduced. So that's where the DOC, diesel oxidation catalyst, and DPF, diesel particulate filter, was introduced. As of 2010, they said, okay, now we need to reduce NOx even further. That's when your SCR/DEF system came into play. Not all manufacturers went with the DEF system and SCR system in 2010, but at this point, all manufacturers use that technology. For EPA 17 and 21, there's some system layout changes. They added a particulate matter sensor, also called a soot sensor. I've been getting a lot of calls and questions on that sensor, so I will touch base a little bit further on that sensor and what it does. So the DPF and DOC, those work together. So your DOC or diesel oxidation catalyst, it has a substrate that is a pass-through device. So if the substrate's open on one end, it's open on the other end, and it's coated with precious metals. So as the exhaust passes through the DOC is creating heat that's needed for regen to occur. So after the exhaust flows through the DOC, it flows into the DPF. Once again, there's some light duty applications that parts may be in a different order. But on class 6 through 8, it goes through the DOC, the exhaust then travels into the DPF. So where the DOC is a pass-through device, that the exhaust is just flowing through the DOC to create the heat that's needed, the DPF actually traps the soot within the channels. So if the channel is open on one end, it's blocked on the other end. If it's blocked on the inlet, open on the outlet, right? So the soot gets trapped in the substrate, and then the substrate it's a porous material, so only the exhaust gas can go through the sidewalls and through the outlet. So then a DPF is going to have a differential pressure sensor that monitors how much soot is in the DPF. And once the DPF is full of soot, the ECM says, okay, we need to do a regen. A regen then burns the soot and turns it to ash. Then we have the SCR system. So that then is to reduce NOx. So after the exhaust exits the DPF, where there is no more soot, it goes through a decomposition tube or mixing chamber. DEF is dosed into the decomposition tube or mixing chamber. The DEF mixed with exhaust goes through the SCR catalyst, and a chemical reaction happens, and the NOx is reduced. So here's the layout of the SCR system. So your SCR is completely separate from your DPF and DOC. So you have an inlet NOx sensor that is monitoring how much NOx is coming in the exhaust coming out of your engine. Based on the amount of NOx, your after treatment control module will then tell the DEF pump that it needs to extract DEF from the tank and send it to the DEF doser. The DEF doser is going to be mounted in the decomposition tube or mixing chamber. The exhaust mixed with the DEF flows through the SCR. The chemical reaction happens. In order to convert NOx, you do need certain temperatures. So there is a temperature sensor involved. And then you have your outlet NOx sensor, and that's there to monitor that the whole system, is working properly and that NOx actually got reduced. So it takes your inlet NOx and your outlet knocks, and the computer says, okay, we've effectively reduced knocks. So regens, there's two types of regens, passive and active. So a passive regen is what we like to have. Your exhaust temps are high. You're driving down a highway. The DPF is full of soot. A regen happens, and it burns in the soot and turns it to ash. If you have low duty cycles, you have maybe an upstream issue causing excessive black smoke where you're just not able to get the temperatures high enough in order to be injected into, or in order for a passive regen to happen, for the soot to burn and turn to ash, then you're going to have fuel that gets injected into the exhaust stream by either an after treatment fuel injector or the injectors on the engine. For example, a Cummins ISB, I believe, uses cylinders 1, 2, and 3 during the exhaust stroke to inject fuel into the exhaust stream. That fuel mixed with the exhaust has a chemical reaction in the DOC to increase temperatures, and then your soot burns off and turns to ash. DPFs are a maintenance item. So every time you're doing that regen, the DPF is filling up with soot. A regen happens, it burns, turns to ash. You fill back up with soot, it burns, turns to ash. So the DPF can only hold so much ash before it needs to be cleaned. It's something that you have to check your maintenance manual to see how often a DPF needs to get cleaned. So for a long haul over the road truck where you don't have excessive idling, you're going to be around every 200 to 250,000 miles. Local stop and go, 100 to 150,000. Severe duty, 75 to 100,000. And anything transit, garbage, high idle, you're going to be 50 to 75,000. But in those cases, you really want to consider doing all of your maintenance, not just DPF cleanings based on your engine hours. So your DPF substrate also has a precious metals coating on it. It is a porous material. A DPF can really be cleaned 2 to 3 times before it's just going to be aged out from failure. So keep that in mind. You've sent your DPF off to get cleaned 3 times. You put it back on and you're having frequent regens or just any sort of after treatment issues, your DPF could just be aged out. I know last month, I feel like we talked a little bit about engine hours and maintenance. So if you're unsure of whether or not you should be doing your maintenance, and this is not just on after treatment, it's also oil changes, fuel filters, air filters, DEF filters. If you're not sure whether or not you should be using hours as an interval versus mileage, the next time you do a PM service, write down your engine hours as well as your mileage. The next time you're due for a service based on miles, if that's what you're currently using, then look at how many engine hours you've gone. All the maintenance manuals have a this many miles or this many hours. So if you've gone over the amount of hours by twice the amount, that's a good indication that you need to switch your services over to hours and not miles. So this is data I had from an ECM image where you can see the amount of miles that are on the truck versus your engine runtime. This also calls out the idle time, but this engine is averaging only 27 miles per hour when really this engine the maintenance manual was built around this engine. It's a Cummins ISX, should be doing an average of 50 miles an hour. So that's something where if you're unsure, it's really easy to track. And then, even just not just after treatment system wise, but like your general engine maintenance, if you said, hey, you have 700,000 miles on this engine, you need a set of injectors, or you have one injector that's bad. Am I trying to tell this person, I'd really suggest a set of injectors? Let's do all 6 instead of just one. but the engine hour equivalent on this engine is as if it has 1.3 million miles on it. So are you going to take into consideration any repair you're doing on that engine based on a 700,000 mile engine versus a 1.3 million mile engine? You're going to maybe make some different choices if you have the knowledge of how many hours you have. So there's a monitoring system that will alert drivers to when there's issues. And, when I'm doing in person classes, I'll say, raise your hand. How often do you get a truck that's towed in because the engine shut down, won't restart, and a check engine light's on? And that's all the information that you've received. You get a work order, check engine light on, or truck shut down, check engine light on. That's it. So I always say that is similar to going to the doctor. Since Tony's always sick, Tony goes to the doctor and says, I don't feel good. Guess what's wrong with me? That's the equivalent of troubleshooting the after treatment system or really any aspect of the engine with the only description on your work order saying check engine lights on. Um, Drivers will often ignore the lights on the dash. They don't know what they mean. I mean, we've talked about technicians haven't had a lot of after treatment trouble or training. Drivers have had even less exposure. So drivers maybe don't understand, hey, I'm having to add a coolant every day. I should report that. Or I've been adding coolant daily and now I got some lights coming up on my dash. I should really report that. Part of it is a lot of times with fleets is that driver doesn't want to drive the spare truck that likely has over 1 million miles on it and it smells like moldy cheese. They don't want their truck to be down in the shop for days getting fixed. So they just keep driving it. Then their truck shuts down. They have no choice but to get it towed in. Even if you have a good service advisor that's asking qualifying questions, you might say to the driver, well, have you added any oil or coolant? The driver might actually lie to you and say no because they think they're going to get into trouble. Oh, I've been adding coolant. I didn't tell anyone. Now my truck had to get towed to a shop. I'm just going to say no. I haven't added anything. Nothing to see here, folks. I've personally had this happen to me when I worked at a shop. I ended up finding out that if I just said, how much oil and how much coolant have you added over the last month? I just would pick a random time frame, right? When you ask a driver how much, they often tell you the correct answer. Like they don't lie to you because it's not a yes or no question. It's how much. And then they think it's okay that they've been adding coolant or oil. Because there's after treatment system troubleshooting that, for example, you're not going to pressure test an EGR cooler if a driver hasn't been adding coolant. If you have an EGR cooler that's leaking, the driver is going to be adding coolant. And if it doesn't get below a certain amount, you're not going to have any codes that are in the ECM saying low coolant. So if you're trying to troubleshoot, say, a frequent regen code, there's a part in the troubleshooting where it's, well, is the driver adding coolant? If yes, pressure test the EGR cooler. If no, don't touch the EGR cooler. Why would you waste your time doing that? Move on with life. So getting accurate information from drivers or even asking them to begin with is critical when trying to troubleshoot the after treatment. Reducing soot and ash, right? The less soot you have that's built up, the less regens you have to do, the less ash you have. So making sure you're using the correct oil is big. My husband has a 2018 Ram with the 6.7 Cummins. We got a letter in the mail that says if the temperature is going to be below freezing for a long period of time, we need to start using a different weight oil only in the winter. Your fuel system, if you have fuel injectors that are weak and they're over fueling, you're going to have excessive black smoke. That means more soot, which means more ash. Air filters, I would say air filters are something that commonly get overlooked for maintenance. I've personally witnessed trucks that had over 200 miles on them that had the original air filter from the factory. So if someone doesn't have a good maintenance practice of replacing their air filters, and I also say this with the DEF filter because it's amazing how many people don't know that there's a DEF filter that needs to be replaced. If you're not able to remember, hey, it's every third PM service or whatever, do it annually when you do your DOT inspection. That's a really easy way to just make sure it's at least getting done. If you have poor airflow, you're going to have poor combustion. Anything that is causing poor combustion means you have excessive soot. Fuel filters, making sure that you have good fuel filters. And I know I took a class Tony put on back in, I think, 2017, where, he had said if he has a lot of fuel system issues, he would keep, I think, baby food jars and send someone to the different fueling stations to see the quality of fuel that are at the fuel stations. And how often is it, is someone saying, well, I'm just going to have my oil changed, but not my fuel filters, or I'll do my fuel filters every other oil change. If your fuel system is not working properly, you will have poor combustion. Um, Turbocharger issues. If you have turbo issues and you have, say, oil going into your exhaust, that's going to create excessive regens. And then the EGR system and coolant consumption. So, coolant will poison the after treatment system. Some engine manufacturers will say, well, if you had an EGR cooler leaking, you can do a DPF restriction test. If it passes, you're good to go. Um, if you've had an EGR cooler that's been leaking for a while and you've had a lot of coolant going into your after treatment system, especially if there's quite a few miles on your truck, at that point, it's worth it to put a new DPF and a new DOC on because coolant will poison the after treatment and it might not pop up immediately, right? You could pass today, but 2 months later end up having issues. So, the biggest part of troubleshooting with a DPF failure is you have to ask questions. You got to sit and do a little bit of research or maybe ask the customer a question. Are you the only shop that has ever worked on this truck? Well, great. You have all of the repair records. But if you've never seen this truck before, it's the first time it's been brought to you, especially I know a lot of people, that probably watch this or even joining us live, you're known for nobody can figure it out. No one knows what's going on. I'm going to, take it to this person, they're going to figure it out. Um, so you might have to go back to your customer and ask them for the repair history. So has the DPF been cleaned on schedule? If the DPF has never been cleaned and it should have been cleaned 100,000 miles ago, well, yeah, the DPF has hardened ash and that might be the problem. How many times has the DPF been cleaned? If it's been cleaned 3 times already, it's maybe that the DPF has just aged out. How long after cleaning or replacement did the DPF fail? So if it's I removed the DPF, had it cleaned, or I put a new one on and a week later it failed again, that's a really, really good indicator that you have an undiagnosed upstream engine issue. Was the DPF packed with soot? A common call I'll get to assist with troubleshooting is I installed a DPF and it just fills up with soot right away. Well, that's an indicator the DPF is doing its job. The DPF isn't creating the soot's coming from your engine. So if you replace a DPF because it was packed with soot and you put a new one on and it's just loading up with soot right away, You either A, don't have your DPF differential pressure tubes installed properly and you're not getting an accurate reading of how much soot is in the DPF, or you have a condition that is causing excessive black smoke. Um, was the DOC previously face plugged? If so, did it get cleaned or replaced? Or is the DOC currently face plugged? If you have a face plugged DOC, that could be because you have extremely high idle time or low temperatures, or you have a condition upstream that's causing improper combustion, which is causing excessive black smoke. And that excessive black smoke will build up on the face of the DOC. Were there any upstream failures in the past? If so, what was it? So you could have an upstream failure. Say you find your turbo is passing oil, your turbo has failed. You put a new turbo on, well, you have oil in your after treatment system. But if you never checked anything with your after treatment system or did anything with it, or you forced a regen and maybe you got a regen to complete successfully, but then a week later, your DPF fails, it could have been from the turbo that just failed. Um, do you have any other engine codes? If you have an after treatment code and any other engine codes, you generally are going to want to troubleshoot those engine codes first. Think of the DPF like the catcher's mitt of the engine, right? Anything that's going on through the engine that is going through the DPF. What's the after treatment history? Can the scan tool you're using, does it allow you to go back and say, I want to look at the temperatures of the last 10 regens? How often are they happening and what are the temperatures? Are there any TSBs related to the after treatment system? Manufacturers are getting better at integrating TSBs into the troubleshooting, but don't count on those TSBs being handed to you. You might have to actually go look for them. There's a TSB for insulation buildup on the face of the DPF. So Cummins had a bunch of DOCs where the insulation was coming off of out of the DOCs and building up on the face of the DPF. You don't want to chase your tail troubleshooting an upstream engine issue because you think that, you have something going on with your DPF when really a TSB is out there to just say, oh, if this is what your DPF looks like, um, then you have, your DOC installations coming apart. And then there is DPF and DOC reuse guidelines. So it doesn't matter if you have a pickup truck, if you have a class 8 truck. Cummins has a really good DPF and DOC reuse guideline document, and you can apply their information to any after treatment system. Because it's, if a DPF melts, you likely either have fuel or oil entering your exhaust. It doesn't matter if it's a Cummins DPF or a DPF on a Ram or, a Duramax or any truck. If you have a melted DPF, it's likely excessive fuel or oil. So visually compare what your DPF or DOC looks like to the DPF and DOC reuse guidelines. Really common codes that will come up are either a frequent regen code or just a DPF differential pressure code. So a DPF differential pressure code is just saying your DPF is loaded with soot and the system couldn't naturally do a regen. So it trips a code saying your DPF is full of soot. The amount of different upstream issues that can cause that, it's a long list. And pay attention to if you're troubleshooting a code, if it says all solutions must be performed. That means that even if you find a failure, you have to continue on and perform every step of troubleshooting because it's more often than not that you're going to have more than one failure. So different issues could be an air intake restriction. You have any sort of boost leaks. Keep in mind, a bunch of small boost leaks equals one large boost leak, right? So you might find a small boost leak and think to yourself, well, I don't think this small boost leak could be causing that issue, but you have to confirm that you don't have additional boost leaks. Your DPF differential pressure sensor could just be stuck in range. I don't condone throwing parts at trucks, but there does come points where it's like, well, how expensive, and this goes even for a temperature sensor. How expensive is the sensor? How much troubleshooting am I going to go through? What's the age of the sensor? The sensors live in a harsh environment. Um, you got an $80 sensor. If you've gone through all your troubleshooting and you haven't found a failure, you might just want to throw a new sensor on because it could just be stuck in range. Any sort of leaks in the exhaust system, you need to get temperatures of like 9 to 1200 degrees in the DPF in order for a regen to be effective. And if, say, your turbo downpipe is leaking exhaust, you're losing heat. And then your temperatures aren't going to get to where they need to be to do a proper regen. The EGR differential pressure sensor supply ports, just assumed those are always plugged. Um, Anytime you have a DPF differential pressure code or a frequent regen code, make sure you're checking those. The DPF differential pressure sensor tubes, they could be plugged or not installed properly. It's something that often gets looked over because it's something where, the technician that takes a DPF out and puts a new one in might not realize that those tubes have to be installed at a certain angle. And if they are, say, installed at a downward angle, that condensation can build up in those tubes. And when condensation builds up, it's blocking the tubes. Therefore, the pressure sensor can't read properly. Um, Turbo issues. If you have oil usage, there's certain engines that were known for having carbon packed piston rings. So if you have a frequent regen code and it was on the ISX CM2250, if you have the frequent regen code and you're adding excessive amounts of oil, I believe the spec is 1 quart per 750 miles. And if you're adding more than that, you have to look into carbon packed piston rings or just weak injectors. You could have injectors overfueling, creating poor combustion, and your DPF isn't able to handle that excessive black smoke entering the system, or it's just constantly having to regen. I also recommend if you're dropping the exhaust for any reason, right? You're removing the DPF or DOC, do a snap test. So with the truck in neutral with the parking brake set or on a pickup truck in park, start the engine with the after treatment removed, press the throttle to the floor, lift it up, and do that 3 times and look at the smoke coming out of the engine. Some manufacturers will give you a spec. For example, Detroit says that a basketball sized amount of black smoke can come out on the initial throttle snap. After that, you should not see any black smoke coming out of the engine. If you do, then you're going to reset your troubleshooting to excessive black smoke. So that's something where after treatment system issues, if for any reason you're dropping the after treatment, a snap test can really help you with your troubleshooting. I just wanted to touch base on the TSBs. I just picked a random truck. This is an ISX CM2350 X101. And this is the list of TSBs that exist for the after treatment system, right? That's a lot of TSBs. So a customer I helped the other day that had a particulate matter sensor code. That sensor is there to detect if there's soot bypassing your DPF. But the sensors also in themselves just fail. So if you have a particulate matter sensor code, you need to figure out, is the sensor bad or is it detecting particulate matter? The sensor is in a Bluebird bus. I ended up finding a TSB that specifically said, if you're getting a code for the particulate matter sensor and it's on a Bluebird bus, you need to load test your batteries. So I can only assume that maybe The particulate matter sensor is the last sensor in line that's getting voltage sent to it. And if you have batteries that fail load test, you just don't have enough juice to power up that sensor. And you could replace the sensor all you want, but that's not going to fix your problem if the cause is your batteries. And nobody's going to go into troubleshooting, an after treatment issue and say, wonder if my batteries are bad. That's not the first thing you go to. That's why going through the TSBs is so critical, because you can save yourself a lot of time. So essentially, anytime you have an after treatment system part fail, you ask yourself, why did it fail? Kind of like a turbo. If a turbocharger is going to last millions of miles if it has clean oil and clean air. If a turbo fails, you figure out, why did the turbo fail? Your after treatment system essentially is no different. It's really, really easy, I feel like, to diagnose that an after treatment part failed, but it's saying, well, what caused it to fail? Is really, I think, what trips up a lot of people. It's they learn hard lessons of, the after treatment failed, I replaced the part, it failed again. I replaced it again, it failed again. And a lot of us, we're an aftermarket manufacturer, although we do manufacture parts for OEMs as well. Someone buys an aftermarket part, and if it fails right away, they're really quick to blame, well, because it's an aftermarket part. But they could buy that same part from the OEM, and the part's going to fail as well if they don't diagnose the upstream engine issue. So that's all I have for today. I know my trainings are usually anywhere from an hour and a half to 3.5 hours, and I was trying to condense a lot of information into a short period of time.
Well, we appreciate what you did. You actually brought up some good points, though, I will say. You got a few questions there. Let's see. We got well, first of all, the first one was Lee. He said, can a DPF be weighed to evaluate cleaning?
There's some cleaning companies that may use weight to say, okay, this is how clean we got it. Essentially, the most popular method of cleaning, we call it a bake and blow. So the DPF gets baked in a kiln that simulates a regen, so that any residual soot that's in the DPF gets burned off and turned to ash, and then it gets pneumatically cleaned to blow the ash out. And then it measures inches in water. It takes a measurement, and then there's a chart that says, well, this part number specifically should measure within these ranges. And if you get to green, say you're 2.6 is your spec, or there's a range of 0.5. So if spec it for green is 2.6 to 3.1, and after cleaning you measure within that, then you've removed enough ash to return it to good operating condition.
Right.
I wouldn't take too much from saying, oh, well, we waited, or this cleaning method got that much more ash out of it than the other. At the end of the day, a bake and blow is the minimum that you would do.
All righty. Joshua had said, but I actually answered him a little bit, but he said, with erratic fuel quality, it's fair to recommend customers to treat the fuel with additives. So, and I went ahead and just said, yeah, we're living in an era now that additives would help substantially. So yeah, I did that one, and I think we had one from Matthew. Yeah, Matthew said, how can we access the reuse of guidelines? Matthew might have to help me on this one.
Oh, the
Was
DPF and DOC reuse guidelines. I can email you a copy, Matthew.
There you go. All righty, very good. Let's see. Yes. So flow is better than weight. Yes, I would agree. So would you agree too, Mara?
I would agree, because there's standardized data. I don't know if somebody has data on, a brand new DPF weighs this much, and also is it an OEM DPF versus an aftermarket DPF? You can have tolerances of, someone standardized the weight of a brand new DPF. How many brand new DPFs did they measure to come up with an average? So I would go with flow. That's kind of the standard.
Exactly. Okay, I know that my DPF cleaning people here in town, they actually do flow tests. And they give me a flow report with the DPF once they clean it. So yeah. All right, very good. Matthew was asking, we talked about this last time, was do we have anything else to verify? And Mara had said last meeting about removing the doser and see if the two knock sensors read the same, correct, Mara?
Yeah.
About verifying knock sensor. See, even I remember. There you go. There you go. She taught me that. All right, very good. Any other questions anybody like to ask Mara?
Maria, I have one. Out of all my years, I've never heard of that word polymerization. What the hell is that?
Polymerization.
It was on one near the end of your slides. You had crystallization / polymerization.
Be the oil.
Could
Was
that
it
be?
on one of the TSBs?
No, it was
Yeah.
before that.
Yeah, it was the last. I can look up that TSB real quick.
I've never heard the term. I was just wondering what it was.
I'm gonna say it's probably the same as crystallization, where if you have a DEF doser that's leaking, when DEF is exposed to air, or if there's too much DEF being dosed into your decomposition tube or mixing chamber, it's gonna crystallize.
Perfect.
And then you get blockage built up within your decomposition tube, and you're not going to be able to then have the flow of exhaust mixed with DEF going into your SCR. So if it's a DEF doser that's leaking, or maybe you have a DEF doser gasket that's leaking, that's allowing that DEF to be exposed to air, and then it crystallizes and builds up in the pipe. But I can look up that specific TSB. It was just I took a bunch of screenshots of the long list of TSBs to show, there's a lot outside of just the general troubleshooting that you would need to reference.
Exactly. Josh was asking, how often have you had or ever had assembly of a 6.7? I don't know if Mara deals with the 6.7 power stroke diesel, but that's actually a very, very wide question, because I have had brand new assemblies on the 6.7 actually get ash loaded within 5,000 miles. And this thing had some serious blow by. But we also questioned the oil. Average life that we obviously see on the 6.7, it all depends how it's driven. Does it see a lot of idle time? Does it see a lot of what weather's it in? The maintenance also affects that. So to answer your question, it's a variable. It's too big. We have had them go as little as 5,000. Like I said, we had to get it all clean, to all the way to over 300,000 miles, because this truck was a hotshot truck and actually saw a lot of highway time. It was always loaded. It was maintained. So therefore, it can range from there. But the average life that I can say from my experience, and Lee, you can chime in on that question, is that the average that we see is about somewhere around 125, 150,000. But like I said, if it sees a lot of hours, it sees a lot of idle time, it sees a lot, it's actually going to be a lot more frequently, because of the fact that it does not see the road time. Now, just to give you an example, last week where I was at a shop teaching, we actually did live diagnostics on the trucks they had in the shop. And there was quite a few trucks that just needed that runtime. And in many cases, we had to run a regeneration just to get it hot enough to actually clear the SCR warning, because it was never able to warm enough for it to take a NOx measurement. So therefore, all we had to do was run a regen, do a few drive cycles, and that fixed the check engine light for that fluid quality performance. So therefore, it's a variable. So if you do have, well, I'm looking at your question here. Ambulance, yeah. If it sees a lot of idle time, yeah, you're going to be doing it a lot more frequently. But you know, you can actually do a regeneration. So those kind of fleets that I deal with, and Mara, I'm sure you come across this with fleets where they do a lot of idle time, a lot of stop and go. Maybe they never see 30 miles an hour. We actually tell them that in their maintenance schedules or their PM services, go ahead and include a regeneration event, because sometimes heat is the magic number. We're not reaching light off temperatures.
So we had a customer locally when I worked at a dealership that it was when after treatment was just coming out. It was brand new, right? So it was new to everyone, even the OEMs. And they were having a lot of after treatment issues, and they were on garbage trucks and plow trucks that didn't see a lot of highway time. And what they did is they created what they called a hot lap, where they would take it out once a week for about 45 minutes and drive it like you stole it. Because it's not just that carbon buildup and the soot buildup within the DPF, you have carbon buildup within your engine. You need to get your exhaust temperatures really high, as high as you can. And so if you have a route that you could say, hey, 1 hour a week, we're just going to go drive it on the interstate and get some highway miles put on it, you're going to see less issues.
Exactly. All right. Very good. Good questions. Thank you. Thank you very much. So,
Tony,
yes, Matthew.
I have a comment and some questions if you don't mind, if we have time for it.
Go ahead.
So Mara brought up this thing about oil, just briefly, and one of my questions is, and then I get to, a comment and question. Are we seeing still issues with high ash oils? Is there issues she's seeing that in the industry, or has most engine oils been now moved to low ash, or we're not seeing a problem with the oil? And then I got some comments that relate then to that oil factor.
Well, so it's making sure you're using the correct oil that your engine calls for. So to say, well, for example, and this is for coolant, not oil, but we had our thermostat replaced on our truck under warranty, right? So a few weeks later, the coolant was just below minimum. And, I wasn't really worried about it because it's like, yep, we just had work done on the cooling system. We'll just go top it off and keep an eye on it. So we go to an auto parts store and I'm asking them for a specific coolant. And the person working was like, oh, you could just use this coolant. It'll work in anything. And I'm like, well, no. Nope, we're good. I'll go somewhere else because they didn't have the coolant that we needed. So it's, similar to with oil, where yes, it's a specific oil with low ash content that you need to be using, and what weight oil, and how many people are maybe just saying, hey, any old 15W40 will work. You got to check your owner's manual to see what specific oil you should be using for that engine. And some of them are backwards compatible, where it's whatever, weight or type of oil. They may say, well, you can use this in these older engines, but you can't use the oil from the older engines in the newer engines.
Gotcha. Right. Well, here's my comment to some of this too. Now, obviously, you're focusing here on this presentation on medium heavy duty after treatment systems, but I'm starting to see and talk to others too on the light duty pickups, which a lot of us here on this call deal with, that are seeing or hearing of roller tappet lifter problems on the 19 and up Ram Cummins. And it's sounding like, from what I'm hearing, quite widespread out there. And I had an interesting conversation with my oil vendor in relation to that. So Ram Cummins went to a roller tappet hydraulic lifter over the conventional flat tappet design. And in talking with my oil provider, I thought it was kind of interesting. So obviously we're going to low ash oil and reducing zinc, and I think phosphorus was the things he told me is one of the things to help reduce the ash content in the oils. And if here's one of the factors, when you deal with high pressure surfaces, they need more of those ingredients. It's a kind of a delicate balance in trying to keep the enough lubrication properties there for the high pressure surfaces within the oil, but yet have it where it's not contaminating the DPFs. And I think possibly if you take a look at these later model engines are now dropping back to like 1030 oils, lower viscosity, which also obviously affects the longer or trying to get a little more fuel economy, etc. But also there's apparently a connection, which he said is true, that these OEMs are trying to get away from higher friction type factors like that flat tappet deal in order to try to offset and lower the phosphorus and zinc content in the oils to lessen the contamination of the DPF. So I thought it was kind of an interesting play on what's actually happening in the oil world and translating to the actual mechanics within the engines.
Yeah.
Yeah, there is a TSB that states for the 2018 and older Ram that you're supposed to use 15W40. That is a CJ4. And then the 2019 and newer, it's recommended to use a 10W30 that's CK4. Now, that may be hey.
Well, CK4 has replaced CJ4.
What?
CK4 has replaced CJ4.
Yep. So the owner's manual might state something different than what the TSB states. I don't know. I haven't looked at an owner's manual, but it's if someone's didn't get the memo, or this came out in 2023. So they maybe are like, hey, we have a bunch of issues. We need to figure out what the issue is. And if they decided, changing, the type of oil and the weight of oil is going to fix these issues, then you need to really follow those guidelines, or you're just going to keep having failures.
Very good. Yes. Answer your question there, Matthew. Matthew?
Sorry, I had it on mute. Yes. So I think that the question was answered. I was just thought it was interesting that information, how that's interacting with the mechanical parts of things too, from the OEM, our development side of things. I guess that manufacturer with the oil company was expressing there is a correlation between what's happening with lubrication / trying to balance that emission, that we're not impacting the DPF filling up, but yet trying to reduce the amount of things in the oils and not yet affect engine life. So I thought that was kind of an interesting correlation.
Righty. Very good. Obviously, like Mara said, we want to follow what recommendations are. Like she's talked about the CK4 oils. And Mara, I don't know if you know, but under the Tech Talk with Ford, which is Ford YouTube channel, they are not recommending the use of CK4. So, nor CJ4. So, well, CJ4, yeah, but of the phosphorus compounds. And if you watch that short video on their YouTube channel where they're talking about their WSS oils. So in other words, they have come up with their own certification. So engine oils had to step up and actually have to meet not only the CK4 standard, but also the WSS for Ford standard. So kind of interesting the way that worked with them. So there you go. Anyways, Mara, you're an angel. Thank you. And please know, people, Mara took time out of her busy schedule to actually make time to give us a presentation. So Mara, we thank you. Thank you for presenting. We look forward to seeing your pretty face in our future roundtable. So we thank you. So I'm going to finish up. Just a quick note to stay on track with what Mara was saying. I did this back in 22 roundtable. Just a quick review for some of you. The LZO, the LM2 inline 6. So just so you guys can no, I'm not going to talk about the Platinum, but I am going to briefly talk about the newest thing that's been around actually for a while now, which is SCR on F. SCR on F, people, is again the select catalyst reduction or the NOx reducing catalyst with the DPF as one unit. So if you look at the The imports, such as your Mercedes-Benz and your Audis, diesels, those actually have SCR on F. So as we look at a nice pretty picture here of one, you're going to notice that the turbo is actually reversed. Exhaust flows out towards the front. And I don't know if you guys can see my cursor, but in this case, what it is, we see going out to the front. And then at that point, we have our DOC, our diesel oxidation catalyst. And then we have our SCR on F. In other words, there's your doser. And in this case, it is coolant cooled. But what it is that, again, the SCR and the DPF are all in one unit on these GMC, Chevy Chevy Silverados, and your Yukons. So in this case, once again, DOC, then SCR on F, and then afterwards, we have another DOC and another NOx catalyst downstream. The beauty of this thing is the fact that we are running through this DPF, which is part of the SCR on F, and we're filtering that soot before it goes in the EGR cooler. So that's pretty cool. In other words, the gas is already filtered of heavy soot from that DPF they're using. And in this case, at that point, that gets introduced into the EGR system. So as we look at it a little bit closer, let me skip these steps because of time. But what you're going to see is that, again, there's your doser, which is liquid cooled. But as we look at the assembly a little bit more in pieces, there we go. So again, you can see the first one is, again, your DOC, then your SCR on F. Then there's actually your flange for the EGR. And then afterwards, we have I can't say throttle plate, it's an exhaust plate. So think of it as throttle plate put in exhaust plate. So that's actually a thermactor type of device. In other words, we had this back in the old big block Chevys where we actually used to restrict the exhaust to get more heat. So at that point, as we look at number 6, we see that's another NOx assembly, another NOx reducing catalyst, and then we have another diesel oxidation catalyst at the end. So we have a total of 1, 2, 3, 4 catalysts in this vehicle. But what you're going to notice, it's really close upstream to the whole engine assembly, for the simple fact that we are encouraging passive regeneration, passive heating, because when it all comes down to, when we're talking about after treatment system, and I proved it last week working on all these trucks, is we're just not getting hot enough. In other words, we're not reaching light off temperatures is the correct term. So again, please make note that these newer vehicles that will be coming out, depending how these emission standards go with our current administration, we're going to see what happens. But in this case, we are now seeing, as you can see that canister afterwards, is that we have now included the DPF and the SCR catalyst or NOx reducing catalyst as one unit. So that's what you're going to see there. So needless to say, those vehicles that I have worked on that have this 3-liter inline 6 haven't had too many issues with the after treatment. There's been a few flash updates for it, but overall it is taking advantage of the exhaust heat. So a lot of passive regenerations. And not to mention, if those engines, like Mara had mentioned earlier too as well, those engines that have post injections, that is actually detrimental, because if I had my choice of having a dedicated injector to inject fuel downstream or have post injections is very bad, for the simple fact that we're injecting fuel into the exhaust stroke, which promotes, again, carbon coking pretty much around the rings of the piston, and thus promote blow by. So yeah. So therefore, just make a note that this is already have changed. This has been going on now for quite a few years, and we're going to see even further changes with future diesel after treatment systems. So we'll see what happens. And for those of you that are gasoline and auto and diesel people, guess who's picking up this coming year? Particulate filters is gasoline application. So that's going to be interesting. So they're going to have fun with what we deal with, which is D-rate conditions. So one thing that, D-rate is a big issue. So, and obviously those trucks that I dealt with last week, they actually had 2 that were going into D-rate. But again, the fix was that we had to get that exhaust after treatment nice and hot. It just was not getting hot. First of all, the climate that we're in Denver, it was cold. And 2 is the fact the way the vehicle is driven, just not getting hot enough. So, all righty. So that's it. We're at about my time says the 10 o'clock hour. We got a few questions here. Let me see what we got here. Matt has left us, and Matt, he's a good guy. Mara, they say thank you to you. Joshua did too, and so does Matthew. So you're gaining some creds here.
Yeah.
I just kidding.
Yeah. an after treatment fuel injector, some manufacturers have that listed as a maintenance item. That it should be replaced or, do a flow check and a leak check on it every X amount of miles. So that's something to keep in mind too, that some manufacturers, people don't realize that after treatment fuel injector, if it leaks, sends too much fuel, takes out your DPF and or your DOC, an
Oh,
after
they get
treatment
clogged.
injector is
Yeah.
a lot cheaper than your after treatment system.
There you go. Well, it's time. Some people got to go back to work. I have to get to work. Mara probably has to get to work.
Same.
So, Mara, once again, super thank yous. Super thank yous to all of you that attended. And those of you that are watching the recording, we will be in contact with giving you our contact information later on. So don't worry with that. I'm ready to go. Mara, once again, have a great afternoon. And everybody
Thanks.
else, have a great afternoon. And we're signing off. And God bless until next month, which is tomorrow, but until the end of next month. So there you go. Thank you, everybody. Everybody take care and God bless.
Thanks. You too.